For the problem 2, from my lecture notes, page 1 to 50, collect the definitions of probabilities of stochastic processes. There's 8 questions. The first one is what is a stationary process? Second one is independent increment process. Third is Markov process. Fourth one is normal process. Fifth one is strict sense stationary process. Six is white noise. Seven means aggregatic process. And eight is Martinez not required. So for the first problem, a stochastic process is called the Wide-Sense stationary process if its mean is a constant and the autocorrelation is a function of time difference. WSS only uses mean and autocorrelation, and the autocorrelation function are T1, T2 for T1 equal to 2. So we see that when the input is WSS process, the output of a stable LTI system is also WSS. For the second problem, independent increment process means xt1 minus xt2 and xt3 minus xt4 on non-overlapping intervals are independent. So the Push process, random walk, and the winning process are independent increment processes. It seems independent increment property is somehow related to Markov process. For the third problem, a process xt is a Markov process if the past has no influence on the future when the present is known. So Push process, Pushing imposes semi-random telegram graph, random telegraph, random walk, and winner process are all Markov process. For the fourth normal process, a process xt is said to be normal if the random variables xt1, xt2 to xtn are jointly normal for any n, any t1, t2 to tn. So fx, x1, x2 to xn, t1, t2 to tn equal to 1 over 2 pi root the power of n multiple delta c root multiple e the power of negative 1 over 2 multiple x minus n the power of t c the power of negative 1 multiple x minus 1 n, where x equal to x1 to xn, capital X equal to xt1 to xtn, n equal to ex, c equal to ex minus n multiple x minus n the power of t. And for the fifth, a process is said to be a strict sense stationary process if its status is not affected by a shift on the time axis. SSS process requires fx, x1, x2 to xn, x1, x2 to xn, f capital X, x1, x2 to xn, t1 plus e, t2 plus e to tn plus e. The condition is very hard to meet. For the sixth white noise is, so Vt equal to delta Wt over delta T. So Vt equal to delta E Wt over delta T equal to 0. And Rv T1 T2 equal to alpha the T1 minus T2. When a process Wt doesn't have derivative, we use Vt equal to dWt over delta T as a notation. So we can get a stochastic process Vt is said to be a white noise if E Vt equals 0 and Rv T1 T2 equal to qt1 multiple t1 minus t2. For the seventh stochastic process, xt is said to be mean algebraic process f limiting capital T to infinity 1 over 2 capital T integral from negative t to t xt delta t equal to e xt in mean square sense. In mean square sense is one kind of consistency. There are the others in probability with probability 1. And in this course we discuss this in mean square sense only.